So in the last video I just talked about Th1 cells, now I'm talking about Th2. And then just like with the previous video, I'm going to talk about their differentiation and effector function. And this is kind of where we're starting to get to the point in immunology where we're not 100% sure about some of the stuff, and a lot of the stuff is hypothesized. And even in like what the stuff that they're saying in my textbook, that's just a lot of it is just an educated guess. Some of it is possibly wrong, but for differentiation, we know for a fact that interleukin 4 is the cytokine that plays a role in that. And we talk about speaking of guesses and things like that. Basophils, we always really don't talk about them too much in this, but I think in the future what we're going to find out is that basophils are really important to the immune system. Like, they have a very dynamic role, because we think, at least, that basophils are playing a role in this, which makes sense because Th2 CD4 T cells are all about expelling parasites from the body, so this would make sense. This is a hypothesis. This is not confirmed. Anyways, interleukin 4 leads to the production of the transcription factor known as Th2, and then Th2 causes differentiation, which results in the production of interleukin 4, which results in the production of Th2, which, this story is nothing new here. So just like with Th1 CD4 cells, we have a positive feedback loop, which can result in a polarization event. So for their effector function, as I had previously mentioned, this is involved in orchestrating a coordinated attack against parasites. And usually whenever I say this, I mean that we're talking about multicellular parasites that are embedded in tissue, things that are too big for us to phagocytize. And the way that we do that is by killing it, one, with inflammation, and then two, literally expelling it from the body and everything in its surrounding area. Whereas they're all kind of doing the same thing, we have specific cytokines that play roles in that, and I'm just going to kind of branch these off based off of the cytokines. Okay, so we have macrophage activation, IgE isotype switching, inflammation of the epithelia, and then smooth muscle contraction, which all this stuff collectively comes together to play a role in trying to cause inflammation to kill it, and then to flush out whatever remains of it. This is interesting to me because a lot of people hypothesize, at least, that parasites are somehow related to inflammatory diseases, and while I don't quite agree with that, parasites have a hell of a lot of biodiversity, and in the future we're going to see them playing, I think, a larger role in terms of biotechnology. I mean, if you look at what we've discovered with CRISPR and Escherichia coli, imagine what we could find in organisms that are multicellular and have sex. Sorry, I like parasites, so I'm probably getting a little bit off track here. But the next is interleukin 5. So interleukin 5 plays a role in IgA isotype switching, and then lastly, eosinophil activation. And then lastly, interleukins 3 and interleukins 9 play roles in activating basophils or mast cells.